Today's lesson is 5-3, Solving Systems Using Substitution. In your workbook, it'll be on page 282. So we've talked about there are 3 ways to solve a system. One is by graphing, and we just got done with that. It is by far the easiest way of solving a system, but it does have its limitations. It's really good if you have small whole numbers or integers, but once you get into large numbers or fractions or decimals or irrational numbers, that's probably not the one you're going to want to use. So option number 2 is substitution, and that's the one our lesson is over today. So again, I am on page 282. Example 1 says, Gemma sells tickets at a local fair. On Saturday, she sells 800 tickets and collects a total of $7,680. How can Gemma determine the number of each type of ticket that was sold on Saturday? So for this one, they're going to actually have us build the equations. So I know that she sold 800 tickets, and I know that those 800 tickets are going to be partially, some are going to be adult tickets, and some of them are going to be children's tickets. I also know that she collected a total of $7,680. It's important for us to notice that we have some ticket prices right here. So we are going to build 2 equations. One has to do with how many tickets, and one has to do with the money. All right, so they went ahead and they created these 2 equations. We have the children's tickets, C, plus the adult tickets, A, is the total tickets of 800. And so this first one right here is going to be tickets. And the second equation, that is all about money. So you're going to take $750 times every child's ticket, plus $1350 times every adult ticket, and you'll get a grand total of $7,680. Now I'm pretty sure that would not be good to graph. So let's substitute. In substitution, you really want one variable by itself. And if you looked at our 2 equations, I don't have a variable by itself, but I can force a variable to be by itself. So let's think about the tickets. Remember, this was our equation right here. And I can easily isolate one of the variables. If I want C, the children's tickets, to be by themselves, I simply am going to subtract A from each side. So C is equal to 800 minus A. Now that's important because I'm going to take this second equation. This is the substitution method, remember? And I am going to take this 800 minus A, and I'm going to fill it in where the C variable used to sit. So if you remember, we took $750 times the children's tickets. Well, instead of C, I'm going to put my 800 minus A in there. And then we just continue, plus $1350 times every adult ticket equals the grand total of $7,680. So we have to use some of our old math skills. We have to distribute. 750 times 800 is 6,000. 750 times A is 750A. And I'm just going to copy. Another old skill was when we put like terms together. So if I added negative 750A plus 1350A, I would have had 6 A's equals 7,680. This, my friends, is a 2-step equation. So we're going to subtract 6,000 from each side, and that's how they got right here. They skipped a couple steps, which I'm not a fan of, so I put them in for us. You'll divide both sides by 6 and you'll get 280 tickets were sold for the adults. Well, that's half of it. I know 280 adult tickets were sold, and I know 800 total tickets were sold, so I bet I can figure out how many children's tickets were sold. And here we go. We knew there were 280. We need another 520 children's tickets. So our answer is 520 children's tickets and 280 adult tickets were sold on Saturday. All right, this is the try it at the bottom of page 282. It said that Brandon took a 50-question exam with a total of 160 points. So let me change my color on that. A total of 160 points. There were X 2-point questions and there were Y 5-point questions. How many of each kind of questions were there? So let's look at what's going on here. X is one kind of question, Y is the other kind of question, and there's a total of 50 questions. So they went ahead and they made an equation for that. And then they did points. So this one is total points. 2-point questions plus 5-point questions gives you 160 points. Now looking at this, neither one of those equations has a variable that's isolated, but I can totally force a variable to be isolated. So I'm going to look at this equation right here. And they're telling me they want Y by itself, so that means I have to subtract X off of each side. So I'm going to have, I'm going to have 50 minus X. I'm going to take this and I'm going to put it right here in the second equation. Instead of a Y, I'm going to write that. So notice they've got the 2X, they've got the plus, they've got the 5, and instead of a Y, we're going to put 50 minus X. Okay, here comes all those old math skills. Copy, copy. 5 times 50 is 250. 5 times X is 5X. Now let's combine, let's clean up. 2X's minus 5X's is negative 3X's, and I have a 250 on one side and I have 160 on the other. I'm going to add or subtract first, so I'm going to get rid of my 250. Bring now negative 3X on one side and negative 90 on the other. Divide by negative 3. And I think that X is going to be 30. Whoops, that came out a little crazy. Let me undo that. X equals 30. So right up here, there are 30 2-point questions. And if there's 50 questions altogether and 30 of them are X's, then there are 20 5-point questions. All right, substitution uses lots and lots of old algebra. So if you need to pause me and copy all of that, you go for it. All right, this is example number 2 on page 283. It says Seiko takes pottery classes at 2 different studios. Is there a number of hours for which Seiko's cost is the same at both studios? So they already wrote our system. This one is $14 per hour. And this one is $28 per hour plus $15 for clay. And I think I see a typo. I think this is supposed to be a parenthesis. Whoop. Let me get a pen instead of a highlighter. This is supposed to be a parenthesis. Okay. So, because y is equal to both of those things, I'm simply going to put a 14x in place of that y. Right there. And I'm going to write out the rest of that second equation. I'm going to take half of 28x and get 14x. I'm going to take half of 15 and make 750. There's not going to ever be a time that this is going to work out. 14x on one side, 14x plus 750 on the other. It doesn't matter what your variables are going to be. This one is never going to work out. It has no solution. This is example 3 on page 283. And they gave us our two equations. Here's one, and here's the other one. And they went through a bunch of steps right here so that they could isolate their variable. They wanted x to be by itself, so they added two y's to both sides, and then they divided by -1. So now x is here. In the second equation, instead of an x, right, oops, let me use a pen, not a highlighter. Do you see this x right here? We're not going to use x, we're going to use this. So they did 3 times, instead of x, they put it right there. And then they just copied plus 6 equals 254.73. Distribute, answer. Distribute, answer. Clean up. Those cancel. So that means I've got this equals this, and that always will be the case, no matter what your variables are. And so you're going to have an infinitely many solutions. All right, we got to the bottom of page 283. There are 2 triads down there. I want you to pause me and work on both of them. Try them by yourselves and then come back for checking. All right, on this first one, I'm going to solve for y. And in order to get y by itself, I have to subtract 1/2 x from both sides. And so that will be my y. I'm going to substitute. Instead of the y, I'm going to put this, -1/2 x plus 3, and then copy, copy, copy. I'm going to distribute. 4 times -1/2 x is -2x. 4 times 3 is 12. Copy, copy, copy. Notice if I combine like terms, those are going to cancel. And there is no value for x and y that is ever going to make that work. There is no solution. All right, for the second one, I'm going to plug this whole thing in right there. I'm not going to use the y. I'm going to take 8, and instead of y, I'm going to put 1/4 x minus 2, and then I'm just going to copy the rest. Minus 2x equals -16. All right, I am going to distribute. 8 times 1/4 x is 2x. 8 times 2 is 16. Copy, copy, copy. When I go to combine like terms, look what happens. Those are going to cancel. And that means this is going to be a true statement every time, no matter what your variables are. And so there are infinitely many solutions. All right, here are your key concepts on page 284. Systems of linear equations can be solved algebraically. When one of the equations can be easily solved for one of the variables, you can use substitution to solve the system efficiently. Step 1, solve one of the equations for one of the variables. Then substitute the expression into the other equation and solve. And then once you have one of the variables, you will calculate the secondary.